and welcome. So, hello internet. This is a video to show you how to interface the Arduino board to LabVIEW. Now, there are many videos for doing this interface, but since I am teaching a class for electrical engineers and they need to know how to do it, so I don't know, maybe they feel better hearing it from my voice. If you don't like my voice, you can change to another video. Anyway, so let's get started. First, of course, you will need the Arduino board, which you have right here. Fresh, new, not opened. So let's see. Take it out from here. And I have the Arduino board. And some stickers. Yay. Okay. Now, first thing you need to know that you have to mount it correctly on your breadboard, so avoiding it to be moved and ruining your experimentation. So you have to decide first on let's say a format how you're gonna place it. I'll say I will place it like this because I'm gonna bring the USB cable from this side. So how do you fix it? With thumb screws, of course. So you place the thumb pin here and another thumb pin here, and this thing ain't going anywhere. Great. So now we take a USB cable, B-type USB cable, similar to what you connect in your printers. Connect it on one side here and connect the other side to your computer USB port. By the way, you have to have the Arduino IDE installed on your computer. So I plugged it in. Let's see, is computer detecting anything? Are you detecting anything? Come on, dude. Don't leave me hanging. Did you detect or anything? Okay, let's check my computer if it's connected or not. It is blinking, so there is power. Device manager. Ah, it's detecting, okay. Let's check, did it get detected or not? COM ports. Yep, here it is, Arduino. I'm running it right now on Windows 8, so if it doesn't work for you guys, maybe you have to do it manually, install the driver manually. If you have a problem, you can come to me at my lab. Those are my students. Other guys, well, Google the problem. Anyway, continuing on. So the board is blinking right now, and that's about it for the connection of the hardware right now. Now you have to have two things, or actually three things on your computer. So the first thing, you have to have the Arduino IDE installed, and then you have to have LabVIEW installed on your computer, and secondly you have to have VI package manager installed. So assuming that LabVIEW is already installed, you can get the LabVIEW package manager from this link, download it, install it as freeware, and the Arduino IDE from the Arduino website itself. Download version 1.0.5 for the time being. Anything newer than that I cannot say what might happen. Probably nothing, but just in case, to avoid any problems. So once you have installed Arduino IDE and the VI package manager, double click on the VI package manager. It will start loading up. Yeah. So this is the VI package manager. Basically, people develop a lot of VIs for certain applications. There are ones for Arduino, there are ones for Leap Motion, there are ones for the AR drone, there are ones for the Connect, and they share them with other LabVIEW developers, as you can see. And one of these two packages is the Arduino. So if you write Arduino in the source, here it is. So as you can see, since the LabVIEW icon is next to it, then I have already installed it. So you just right click on it, install, download and install, and that's it. Close it down, restart LabVIEW, and that's it, you are ready to go. So let's start with a basic LabVIEW application. As you can see, there is an LED blinking on the Arduino board itself. That LED is connected to pin 13 of the Arduino board. So what basically I'm going to do, I will control that LED by a switch inside LabVIEW to turn it on and off as I like. So to start that, let's zoom out a little bit. Go to LabVIEW, select blank VI. Okay, so you have the front panel and the block diagram. Go to the block diagram, full screen it, right click, and search for Arduino. So Arduino, here it is. So first thing, you select the initialize VI. You place it, and then you have to create some inputs for it. So for this one, Visa resources. Visa resources is what you call the serial port that you are using. What serial port are you using to interface with the Arduino? So we will create a constant because I'm not going to change it, and then select that COM port. I think my COM port was, let me check again, properties, device manager. The Arduino's COM port is COM port number 5. Okay, so keep that in mind. So go here, COM number 5, a little bit here. Okay, make everything nice and tidy so you guys can understand. Baud rate, gonna keep it the same, so create constant. Bytes per packet, also keep it constant. Board type, it's an UNO board, so create constant. They have support for Demolover and Mega board, but the UNO is more than enough to what you need to do. And your interface is going to be create constant USB to serial, whether it's FTDI or serial port. You have also an option for XP and Bluetooth module. Not interested in those. So these are constants, you don't change them at all. Now we go back to the Arduino, we go to low level, and then I want to control this IO pin. It's a digital IO pin. So first I have to set the digital pin. Okay, so Arduino resources are connected together. You never change them. Let's move it a little bit down. Okay, now digital IO pin. This one create constant. And what pin I want to control? The one is connected to this LED, which would be pin number 13. Okay, and pin mode. Of course, if I want to turn it on and off, then it has to be a output port. And it's always a common good practice to connect error in and error out together to know if your system crashed, what happened. Go back to Arduino, low level, and then you want to digital write to it. So select digital write. This part I'm going to keep it looping. By looping, I will trap it inside a while loop. So drag this one here and drag this one here, and just for the sake of good code writing, I'll connect this one also here. So resources with resources, error with error, and value. Okay, and digital IO pin still needs to know which pin. In that case, it's going to be pin 13. Now this one, the value, I am going to create a control. Control, if you press Control T, you will find that this numeric entrance has been created on the front panel. Now, since this is a digital pin, you either can write 0 or 1 to it. If you write anything else, it will not be understood by the system. I will fix it later on, maybe show you a little programming trick. You guys probably prefer to see it as a switch, but for the time being, just to demonstrate that it works. So, going back here, so this is done, this is done. Okay, then connect resources back to the output, and finally you select not low level, sorry, Arduino close. This is the communication line between the Arduino and LabVIEW, because if you don't do that, then you risk crashing the Arduino, and then you will have to reset it again. Okay, seems everything is okay. Boom, boom, boom. Yeah, I think it's okay. Oh yeah, while loop you need to put a stop. So create control, so a stop button, so we can stop the program. Anything else? No. At this point we are done with the LabVIEW. Now we need to actually send to the Arduino the interface between it and the LabVIEW software. What do I mean by that? Whatever you create here in LabVIEW, it is not sent to the Arduino. It's not compiled and put on the Arduino chip itself, but actually you are just opening a communication line, serial communication line between LabVIEW and the Arduino, which is running a pre-compiled code that understands that commands that come from LabVIEW and execute them. For example, LabVIEW asks it to read what is the voltage. So Arduino will read the voltage and give it back to LabVIEW through serial. Or for example, LabVIEW wants to turn an LED on. So LabVIEW will send to it a command to turn LED number 1. The Arduino will turn on LED number 1, and so on. So the actual code that you do in LabVIEW does not get compiled and deployed inside the Arduino. It is just communicating with the Arduino board, just for communication sakes. Okay. Now you go to launch the Arduino IDE. You go to File, Open. Go to My Computer, C Drive, Program Files, National Instruments, here it is. Then you select LabVIEW 2011, and then VI library, and then LabVIEW interface for Arduino. Okay, and then firmware, LIFA base, and then select LIFA base. LIFA stands for LabVIEW interface for Arduino. So double click on it. Done. Just to check that it compiles. Checking here, and come on. Boom. Yeah, it's okay. So, but check here. It says it's COM1. So change it to COM5. Compile and send it. Now it's sending. Come on. Finish sending. Come on, dude. Come on. Come on. Come on. Okay. As you can see, the LED already stopped blinking because there's another code inside right now. So, common good practice, once you have sent the LIFA base to the Arduino, close the Arduino IDE. Why? Because you are occupying the COM port that is connected to the Arduino if you keep the IDE open, which will crash with LabVIEW because LabVIEW will try to use the same port. Hoping it's still not crashing. So also it's a good common practice to create an indicator for the error. For if it crashes and you want to know what happened, then the error will give you a feedback. So I see everything is ready here, so let's start. Run, and boom. As you can see now, maybe it's not clear, I'll zoom in for you. Come on, focus. Focus. Pretty please. I'm begging here, come on. Okay. As you can see, the LED itself is off right now because we are sending to it 0. Now if I dash it and make it 1 and enter, the LED is on. And if I dash it again and make it 0, the LED is off. Now that's nice and dandy, but some people might like to see a switch. So let's make this a switch instead of an actual text input. So stop the command. Let's see, so if I remember correctly, first I will need a button. I prefer to use the silver interface because they are better better looking, nothing else. So boolean and then button. Bring it here, and then I think I want to go to boolean and then boolean to 0 or 1. So this is a conversion of data types, so I put this one here, delete this line. Okay, no errors. Let's try it again. Run the code. It's running right now. Switch should be in the off position, so if I press, LED is on. Press again, LED is off. Press on, off. Thank God, it worked. First shooting. No editing, no cutting. Real shit, through and through. Now stop this. Just for you guys to get an idea of what's happening. So I will highlight execution to see what's actually happening when I run the code. So run here. See this information go to the initialization. Initialization communicates and tells you OK. And then the data gets initiated normally, no problems. So once I'm done, if I turn it 1, then boolean 1 gets converted to an integer and then 1. Now if I want to stop it, stop, true, you break out of the while loop, and then you end communication with the Arduino. So I hope you find this useful. Thank you for your time. This is not the end. I am going to still maybe do 2 more examples to show you how to do PWM control and analog read from the Arduino. Thank you for your time and goodbye.